So today's lesson is on standard A1.LFE.16. So let's break down that standard. It says given a linear function in any form. Well, you guys know that linear, that base word, line, a linear function is just going to be a function that when we graph it is going to give us a straight line. This particular standard is just identifying the intercepts of the graph. So when we say the intercepts, we're going to have two of them. We're going to have an x-intercept. And what we're looking for here is where does it intersect the x-axis. For the y-intercept, yes, we're looking for where does it intersect the y-axis. So we can do this a couple different ways, and that is where it comes into play of any form. And so we're going to look at a couple different examples, and within this pair assessment, you may still call it edge elastic, it's going to stop, this video is going to stop a couple times and ask you some questions. The first question is just kind of see what do you know without us even talking about it, just by looking at a graph. After that, after the initial question, I'm going to show you examples. The video will pause and you will work a problem very similar to what you just saw worked out in an example in the video. And then the video will start back once you've answered that question, do another example, and so on. So just make sure that you're paying attention to this video, and then you will have no problems answering these questions. So the first form we're going to look at, I know this is a linear function already graphed for me because I can see that it's the straight line. And if the question was just what is the x and y intercept, so I'm going to zoom this in for you just so that you can see that piece of it. And I want you to just try your best of what do you think are the x and y intercepts. Okay, so looking at this, my x-intercept is going to be where it crosses the x-axis, right? Well, what you have to remember is that our x-axis is our horizontal axis. Our y-axis is going to be our vertical. If this bolded line, that's our linear function when it was graphed, we're looking at where does it intersect the x-axis. And that's going to give us the x-intercept. So if it intercepts the x-axis at a value of x equals 4, the intercept is an actual point. And so think back to even when you started this in 5th grade, graphing in the first quadrant, and then we moved to all 4 quadrants in 6th grade, and of course it just keeps building up. An ordered pair, a point, is going to have the x value and the y value of that point. X coming first. So if the x value is 4, this is nothing different than what you would do any other point. If it's on the x-axis, we haven't moved up or down, so the y value would be 0. So the x-intercept is always going to have whatever the x value is, and the y-intercept's always, or the y value is always going to be 0. So very similar. If we're looking for the y-intercept, we find where does that graph intersect the y-axis, and at that point, that's going to be our y-intercept. We can see that the y value is -3 because here's -2 and -4, so halfway would be -3. Y-intercept, so y value of the point, and I didn't move left or right, so of course that means my x is 0. That again is always going to be the case with any y-intercept. The only time it's going to be able to intercept the y-axis is if the x value is 0. Alright, so now you try this one. Just tell me what the x and y intercepts are when it's already graphed. Now we're going to shift. What if another form is I'm going to give you the equation of a linear function, and let's say I write as y equals 2x plus 1. Remember, what you learned in 8th grade, and you've still continued doing that in 9th grade this year, is the slope-intercept form, y equals mx plus b. You know just by looking at it that the y-intercept is the b, right? Then that means in here in our problem that our y-intercept is positive 1. So without any work, if it's in slope-intercept form, you can tell me the y-intercept is 0, positive 1. Now, if you're going to check that, remember I said if it's the y-intercept, the x value of the y-intercept is always 0. Well, if I plugged in 0 for x into my equation, this is 2 times x, so 2 times 0 is 0, plus 1 would just give me the y value is 1. So when x is 0, y is 1. Okay? So well, we didn't have to do that because it's already in slope-intercept form. But if this is our slope, we could graph it. But what happens sometimes is when we use the y-intercept to graph and then we use our slope to find another point, that x-intercept may be a fraction. It may be hard to tell the exact value. So what we're going to do instead is do the same idea to find the x-intercept. So remember, x-intercept means it's always going to have the 0 value for y, for it to cross the x-axis. So I'm going to just copy down my equation, y equals 2x plus 1. I'm going to plug in 0 for y and see, well, when y is 0, what will x be? I just have a simple linear equation that we're going to solve. So to solve for that x, I'm going to subtract 1 from both sides. And then I'm going to divide both sides by 2. So the x value of the x-intercept is negative 1/2. So now I have my x-intercept is negative 1/2, 0. My y-intercept is 0, 1. If you're going to graph this on Pear Assessment or Atlas, the axes may not be drawn. You could label that anywhere. As far as it does not have to be the middle of a graph. Okay. If it's already drawn for you, then you're a little bit more limited in just the sense that you pay attention to the scale already drawn for you. For example, if I go back here, this was every little boulder mark was 2. So it took, these are by half. So half, negative 1, negative 1.5, negative 2. Half, 1, 1.5, 2. If it's not marked for you, you get to choose the scale. So since I am going to have an intercept of a half, I may call that half, 1. So each marking is worth a half. Now you do not have to label each one. It's understood what your markings represent. Okay, so then really quick, 0, 1, remember that's the y-intercept. We knew that just by looking at y equals mx plus b. Our x-intercept is negative 1/2, 0, so we're just plotting points once you find those intercepts. And we could sketch the graph by connecting our 2 ordered pairs. So when given an equation, you're going to plug in 0 for x to find the y-intercept, 0 for y to find the x-intercept. Now you try one. Okay, what we are going to do next is, what if it's not in slope-intercept form? What if they give us one in standard form? So for example, 3x minus 2y equals 8. There's really no difference other than you have more options. So if you enjoy rewriting it in slope-intercept form, y equals mx plus b, you could do that. Then you would know what your y-intercept is. And then you would have to still plug in 0 for y to find the x-intercept. You could graph it and at least have an estimate. And you're going to have the Desmos calculator, which we're going to do in just a second. Or you just keep the value, the idea that if the x-intercept is going to be some value of x whenever y is 0, the y-intercept is going to be found by plugging in 0 for x. Then all you have to do is do that twice. So if I find my x-intercept first, I'm going to plug in 0 for y and simplify. So this would be 3x minus 2 times 0, which would just be minus 0. So we get 8. Divide both sides by 3. So x equals 8/3. Okay. Same thing for the y-intercept. I'm now plugging in 0 for x and simplifying. So 3 times 0 is 0 minus 2y. Keep the sign that was in front of the 2y. And now divide both sides by -2. So we have y equals -4. And so there are my two intercepts. So now try one that is not in slope-intercept form. Try one that's in standard form. And then the last thing we're going to do is we are going to look at doing one on the calculator. So now let's say that you are given an equation. You struggle sometimes with making sure that you put it in slope-intercept form correctly. And so you want to just confirm, perhaps, or you want to have another method to make sure that you are identifying the intercepts correctly. So let's say I was given the linear function 2x equals 3y plus 2. You could, again, rewrite this in slope-intercept form, but there's a couple more movements you have to make. You could still plug in 0 and solve pretty quickly. Or if you graphed it, notice that the x and y intercepts are labeled for you. Our x-intercept 1, 0 is pretty clearly labeled as such, and you can see it through the intersection. Our y-coordinate, if you hover over, because you can tell that it's not going to be right there on an actual whole number, we do see that it's negative, and hopefully you recognize that 0.6 repeating is a pretty popular decimal. You could always use your handheld and divide to make sure. So that's going to be 0, -2/3. But that is one way, even if you just had an estimate of what the graph would look like, that might let you know, oh yes, I did plug in 0 for x and solve for y correctly. I hope this helps, and good luck with the rest of this lesson.